Hello everyone. I am Mr. S.M. Ganwat, working as Assistant Professor in Mechanical Department at Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkaranji. Today we are going to solve the step bar problem using ANSYS2021R1. The first problem that we are going to solve is consider the step bar shown in figure and determine the nodal displacement, stress in each element and reaction forces. This is the problem given to us. For this problem, we are going to determine nodal displacement, stress in each element and reaction forces. The values given for each section are E is equal to 2 into 10 raised to 5 Newton per mm square. Cross section area for this section is 900 mm square. The length of this section is 600 mm. The second section, the value of E is 0.7 into 10 raised to 5 Newton per mm square. Cross section area for this section is 600 mm square. Length is 500 mm and the force is basically given is 500 Newton. For this example, one end of the bar is fixed and the load is applied at the other end, and we are going to solve this problem by using ANSYS 2021R1 software. Now we'll start with the software process. We'll first start with the file. Click on file, then click on clear and start new. Then we are going to click on do not read file. Click on OK. Click on S. Now for solving the step bar problem, you are supposed to select the preference. We are going to click on the preference. The left side main menu is going to show you the process through which we are going to solve this particular problem. We'll click on the preference. In this preference, we are going to select this structural option for solving the step bar problem. Click on OK. Then the second step in this particular segment is preprocessor part. In preprocessor, there are number of options. First, you are supposed to select the element type. Click on add, edit, delete button. Then click on add button. Then for solving step bar problem, we are going to utilize the link element. Click on link. Then you will get the first option, that is 3D finite strain 180. Click on OK. The link element is added in your element type. Click on close button. Then click on sections. In section, you are supposed to click on the link tab. Link, then click on add button. Then you are supposed to add the section ID. I will add my first section ID as 1. Then click on OK button. Then you can assign the section name to this particular link. I am going to assign the section name as 1. Then in this problem, we are going to generate the area for this particular section, that is first link, and the area given is 900 mm square. Then after clicking on the link add button, section ID is added, section name is 1. I am going to add the area 900 mm square. Click on apply, as we have to add one more section. I am going to click on the apply button. Add link section with ID. Now I am going to choose ID number 2. Click on OK. Section name 2. Link area given to us is, second link area is 600. Section name 2. Link area is 600 mm square. Then click on OK. Then we have added the sections. Then we'll turn towards the material properties. Now after clicking on the material properties, you are supposed to select the material models, click on structural, then linear, elastic, isotropic. EX is going to indicate you the material properties, that is modulus of elasticity. As we have got two different sections with different material properties, we have to generate two material models. The first material model is for first section, second material model is for second section. Then for first section, the value is 2 into 10 raised to 5 Newton per mm square. Then we'll add 2 into 10 raised to 5 value right over EX, and PRXY is basically the Poisson's ratio, which is 0.3. Then click on OK. Then we are going to add another model. Click on material, new model, define material ID as 2, click on OK. Then again you are supposed to follow the same path, that is structural, linear, elastic, isotropic. Click on isotropic, add the second material property for second section. Then the value of E is 0.7 into 10 raised to 5. Then we'll add 0.7 e raised to 5, and the Poisson's ratio is 0.3. Click on OK. Then the material properties are basically defined for both the sections. We'll then move further with the next section, that is modeling. We are going to click on the modeling. We have to create nodes and elements for this step bar problem. Then we are going to click on the create, then click on nodes, then click on in active CS. In active CS means in active coordinate system we are going to generate the nodes. Click on in active CS. Then this window will show you the node numbers and the location in active coordinate system. Then we will assign node number 1. The value for this node is 0, which is at the initial position. Click on apply. Then we are going to create the second node, which is basically placed at this particular section, at the end of first section. The first node is created at this particular section. The second node is created at a distance of 600 mm. Then we'll add node number 2 at distance 600. Click on apply. Node number 3 is created at a distance from origin, which is present at 1100 mm. Then click on OK. You will find the 3 nodes are basically created. Node number 1 is at origin, node number 2 at distance 600 mm, node number 3 at distance 1100 mm from the origin. Now we create the elements from these nodes. Click on elements. Then you are supposed to select the element attribute. Click on element attribute. For first section, the element attribute is element type is link 180. When you are going to click on material number, then you are supposed to select the first material number, section number as 1, and then click on OK. Then you can create the element through second option, that is called as auto numbered. Through nodes, click on through nodes, select first node, second node, click on apply. It will create the first element. Now again click on element attribute, then select the material number as 2, section number as 2, click on OK. Then click on auto numbered through nodes, pick the second node and third node, click on OK. Now the nodes and elements are created. Now we'll proceed further with the next type, that is the assigning the boundary conditions to this particular problem. Now when we'll look at this particular problem, you will see that the one end is basically fixed and the load is applied at the other end. Now what we'll do, we are going to fix the node number 1 and we are going to apply the boundary conditions, that is the load at the node number 3. Now you can visualize the size and shape through plot control, style, size and shape, make the display of elements on. Click on OK, then click on plot, multiplot, and you can view the isometric view of this particular bar section, step bar section. Now we are going to assign the boundary conditions in this problem. Now click on loads, define load, apply structural, click on displacement. Now what we are going to do, we are going to restrict the degrees of freedom present at node number 1. Now click on nodes, pick the particular node, click on apply, then you will get this particular table in which we are going to restrict all degrees of freedom. Click on OK. This will indicate you in this particular figure. Now we are going to apply the force at node number 3. Now click on force, click on node, pick the particular node, click on apply. The direction is fx and I am going to set the value as 500 Newton. Click on OK. The boundary conditions are basically applied in this particular problem. Now this problem means the inputs are basically given to this problem with all respects. We have created nodes, we have created elements, we have assigned the boundary conditions to this particular problem. Now the second phase is the solution part. In solution part, we are going to solve this particular problem for given conditions. Click on solve the current load step, click on OK. You will get the message as solution is done. Now the last part of this segment is the general post processor. After clicking on general post processor, click on read result, first set and last set. Now I am going to click on element table, define table, add, choose the option as by sequence number, click on ls, load step 1, click on OK. The element table is defined for this particular problem. Now click on plot results, counter plot, nodal solution, degrees of freedom, x component, click on OK. You will get the display of the results for nodal solution, means you can list out the maximum displacement and the variation of displacement from one end to another end. The red color is going to indicate you the maximum displacement present at another end, and the variation from 0 to maximum displacement is identified in this particular color bar. Now I can view the element solution as well. Click on element solution, click on stress, von Mises stress, click on OK. You will get the stress distribution for each element. Now you can list these results from the option as list result. Click on list result, then nodal solution, degrees of freedom, x component of displacement. You will get the values of the displacement at each node. Node number 1, as it is fixed, you will get the value as 0. For node number 2, the value is 0.1667 into 10 raised to minus 2, and at node number 3, you will get the displacement as 0.7619 into 10 raised to minus 2. The maximum value you will get at node number 3. You can save this particular file for your documentation work. Now similarly, you can click on element solution, stress, von Mises stresses, click on OK. You will get the element stresses generated for the given step bar problem. Now You can find the reaction solution as well for this particular problem. Click on reaction solution, fx force, click on OK. You will get the reaction, that is reaction will be generated at node number 1, which is having the value as minus 500. This is the reaction solution for the given problem, and you can capture these particular images for your purpose also. Before that, we'll first animate the results that we have got. Click on plot control, click on animate, then click on deformed shape, then deform plus undeform, click on OK. You will get the displacement that is going to happen at node number 2 and node number 3 through this animation. The movement of node number 2 and node number 3 is identified through this animation. You can close this particular window, then you can change the color of the screen as well. Go to style, colors, then reverse video. Then it is possible to capture this particular image in this particular format as just I will click on nodal solution degrees of freedom X component. This is list results, plot results, counter plot, nodal solution, X component. I can capture this particular image from the tool that is plot controls, and I got the option as capture image. Click on capture image, the image will be captured. You can save this particular image for your documentation work. This is all about the step bar problem, and we can make the necessary changes as per the problem assigned to us. As per the conditions given to us, you can assign the boundary conditions as per the requirement. You can generate the nodes and elements for the given problem in this fashion. This is all about. Similarly, I can generate the element solution, von Mises traces. Again, you can go to plot control and you can capture this particular image for your documentation work. This is basically the procedure that is followed to solve the step bar problem for ANSYS2021R1 software. This software is basically utilized to solve such kinds of problems. Thank you.